All right, so the graph of an equation in two variables, x and y, consists of the set of points in the xy plane whose coordinates x comma y satisfy the equations. Right. So given an equation, whatever that is, right, you find points from this equation. You find the x value, you find, and then the corresponding y value. And then when you have a set of points, you just put them on the xy plane or the rectangular coordinate system or the Cartesian coordinate system, and then you connect the points and you have the graph of the equations. All right. Now, in order to see if a point is, or if the point satisfying an equation, what we do is basically you just substitute the point into the equations. When you have a true statement, you say that, okay, the point is on the graph of the equation. If the point does not satisfy the equation, or you have a false statement, you say that the point is not on the graph. All right. So let's take a look at example 1, right? You want to determine if the point 2, 3 and 2, -2 are on the graph of this given equations, right? The equation is 2x minus y equal to 6. Right. So for the point 2, 3, what you do is that you substitute x equal to 2 and y equal to 3 into the equations. So you got 2 times 2 minus 3, and you got 4 minus 3 equal to 1, which is different from 6, right? And therefore, you can conclude that this point is not on the graph of the equations. Thus, 2, 3 is not on the graph of 2x minus y equal to 6. Right. Similarly, for the second point, I'm going to substitute x equal to 2 and y equal to -2 into the equations. So for the point 2, -2, I do 2 times 2 minus -2. So you got 4 plus 2 equal to 6. So that is the true statement right there. Right? When you substitute x value and y value into the equations, you obtain 6, which equals to the right hand side of the equations. So you conclude that 2, -2 is on the graph of the equation 2x minus y equal to 6. The question so far. Am I moving okay? Fast, good pace. All right. Next topic is steps to graph an equation. There are 3 main steps, right? So the first step is to find the points that satisfy the equations. Find points x comma y that satisfy the equations. Let's say the given equations. Now, when you have a point, you have a set of point, you plot this point on the rectangular coordinates. Right, so plot points found in step 1 on the XY plane or the rectangular coordinate system. Now the last step is just to connect the points. To complete the graph of the equations. So the first two steps make sense, right? Now, the last step is not always that easy by just connecting points. You need to kind of understand the shape of the given equation first. Sometimes it's more complicated than we can imagine. All right. So that's why I'm saying in this lecture, so up to this point, we're just going to focus on the graph of a line or graph of a parabola, right? Which we know the shape. If you have enough points, just connect the points together and you have a line. If you will have enough point and you know that is the parabola, then you connect the point following the parabola pattern. Okay, so let's take a look at example 2. That we want to graph this equation y equal to negative 2x plus 3 by plotting points. So this is an equation of a line. In lecture 6, we will spend more time on the equation of a line, but for now, we set up a few points, plot the points on the coordinate system, and then connect the points to see that this given equation is in fact a line. All right, so again, I understand that many of you have seen this material before, yes? Right. Okay, but bear with me here. Hopefully we are on the same page on how to plot the graph of an equation. So usually what I do is I make a table with 2 columns. On the left is the value of x, chose at random. The easier for calculation, better. And on the right, or the right column, is the value of y. So in this case, y is equal to negative 2x plus 3. So usually when you plot points for a line, you start with x equal to 0, x equal to plus and minus 1, x equal to plus and minus 2, things like that. So I'm going to start with 0. Right. So the y value is going to be negative 2 times 0 plus 3. So you get 3. From here, probably it's easier for me to plot. I have the point 0, 3. So x equal to 0, y equal to 3. I need another point. Let's say x equal to 1. So negative 2 times 1 plus 3 give me positive 1. So now I have the second point, 1, 1. Remember, for a line, you just need 2 points to make a line. Okay. But for good measure, let's try another point. Let's say x equal to negative 1. So you have negative 2 times negative 1 plus 3 will give you positive 5. So you have the third point, negative 1, positive 5. Now I'm going to plot this point on the coordinate system. So the first point is 0, 3. The second point is 1, 1. And the third point is negative 1, positive 5. Now I'm going to connect these points together. Got it? Yeah. Any questions on this, on example 2? Now I'm gonna, no question, going once, going twice. All right, move on to number 3, example 3. So let's try to graph the equation y equal to x squared. This is the parabola, right? Again, we will look more closely to parabola later on in the course. But for now, let's just write down some points here for y equal to x squared. Again, I'm going to make a table with 2 columns. So the first column is x, the second column is y equal to x squared. I'm going to consider a bunch of points now, starting with x equal to 0, and then I'm going to choose 1, -1, x equal to 2, -2, and 3, -3, so on and so forth. Okay, so x equal to 0, y equal to 0 square. Give me 0 as well. X equal to 1, y equal to 1 square, or +1. So now I have 2 points. 0, 0. This is 1, 1. The next point I consider is x equal to -1. So y equal to -1 square equal to +1. And I have the third point. X equal to -1, y equal to +1. Now, be very careful when you have a negative number, when you want to square the negative number. So as you can see, I use parentheses about the negative number. Do it near that. So I want to, again, make sure that you see this. Right? This value, -1 squared, is different from this value. You see the difference? This give me +1. This give me -1. You okay? You feeling good about this? Are you sure? Very sure. If I see this, you make this mistake in the test or in the quiz, can I yell at you? No? Yes. Good? Am I serious enough? Yeah. Okay. All right. So I still going to see this mistake, but it's happened. All right. So now let's move on to the next set of points. X equal to 2, x equal to -2. So 2 here. So y equal to 2 square equal to 4. So I have the next point, which is 2, 4. And then one last point, x equal to -2, then y equal to -2 square or +4. So now I have 5 points, right? So how many points should I consider in plotting a parabola? The more points you have, the better the shape going to look, all right? It's always easy to graph a line because you just need 2 points, but for all the shape, the more points you have, the better you can recognize the pattern. All right, so let me put this point on the coordinate system. The first point is 0, 0 right here. 1, 1. Be careful here. So x equal to 1, y equal to 1, x equal to -1, y equal to 1, x equal to 2, y equal to 4, x equal to -2, y equal to 4. All right, I'm gonna try 2 more points, x equal to 3 and x equal to -3. If you do the calculations correctly, x equal to 3, y equal to +9. So up here, and then when x equal to -3, y equal to +9 as well. All right. If you want, you can go crazy on this. X equal to 4, y equal to 16. X equal to -4, y equal to -2 +16. All right. So hopefully with this many points, you can recognize the graph of the parabola. Then you connect these points together. And this is the point that we chose. Good. Questions? Can be any number. Even though it's not always true, the statement that I say that any number. Depends on the function, right? When you have a rational function, you have conditions, then you should not choose the point that align with it. Things like that. But hopefully you get the idea. I convey the idea across that. To plot the point, first you need a bunch of points. Then when you get the points, plot the points on the graph and then connect the points together. All right. The next topic, now you have the graph. The next topic is to find the internship. I just talked about internship for the last hours or so that's why. I just have a meeting with internship and career service office. Intercept, find intercept from a graph. All right, so the point at which the graph crosses or touches the axis called the intercept. Right, so again, the point at which the graph crosses or touches the axis. All right, just to clarify one thing. When I say I talk to internships and career service offices, I'm looking for Java students, not for me. But you here, professor. Don't worry about leaving you in the middle of the semester. Right, good. All right, so axis, there are two types of axes, right? So it's the x-axis and the y-axis. So therefore, you have two types of intercepts, the x-intercept and the y-intercept. So definitions of x-intercept and y-intercept are very similar to the general intercepts. Right. So for the x-intercepts, the point at which the graph crosses or touches the x-axis. Crosses or touches the x-axis. And you have a very similar definitions to the y-intercept. For the y-intercept, the points at which the graph crosses or touches the y-axis. Now let's take a look at example 4. We are given a graph of symmetry. From the graph, can you identify the intercept? The intercepts. What is the x-intercept and what is the y-intercept? So the x-intercept by definition is are points that the graph at which the graph crosses or touches the x-axis. All right, can someone tell me what are the x-intercepts? Okay, so those are the x-intercepts. Right, what about the y-intercept? Somebody else. Y-intercept a point at which the graph touches the y. Very good. Yep. So for x here, so for x-intercepts, you have -3, 0, 3 half, 0, and 4.5, 0. Now for y-intercept, you have 0, 3, 0, -4/3, and 0, -3.5. Right. So from this example, when you get the x-intercept and y-intercept, what do you see the common thing for the x-intercepts? What is the common thing about the y-intercepts? Yes. So for x-intercept, always equal to 0, and for the y-intercepts, x value is always equal to 0, and that is how you use the informations to find the x-intercept and y-intercept algebraically. Okay, so that's the next topic, to finding the intercept algebraically. So for x-intercepts, y is always equal to 0, and for the y-intercept, x is always equal to 0. Now, example 5, given you want to find the x and y intercept of the graph of y equal to x squared minus 9. After you find the information, list the points in order pair form. Order pair form, that means x comma y. Right, so I want both the x value and the y value. So for x-intercept, remember y equal to 0. Right. So that is, you take the equation, you set y equal to 0, and you have x squared minus 9 equal to 0. Then you have x squared minus 9 equal to 0. Again, do you know where it's coming from? Do you understand why we have x squared minus 9 equal to 0? Okay. All right, so there are a couple of ways to obtain the solutions. That is, you can move -9 to the right-hand side and take the square root on both sides of the equation. You with me on that? Or you can factor the left-hand side into x minus 3 times x plus 3. Okay, either one should be fine. So let me move 9 to the right-hand, -9 to the right-hand side. Here you get x squared equal to +9, and then you take the square root on both sides of the equation, and you get plus n minus 3. All right, so therefore it's indicate that you have two different intercepts, x-intercept rather. So the x-intercept are -3, 0 and 3, 0. Now for the y-intercept, you have x equal to 0. That is, in the equation, you set x equal to 0 and you find the y value. So you have y equal to 0 square minus 9, or y value is just negative 9. So the y-intercept is 0, negative 9. Any questions? So let's take a look at example 6. It's going to be very similar to example 5. That is, you need to find x and y intercepts given the following equations. Okay. So again, when you consider x-intercept or trying to find x-intercept, you set y equal to 0. When you find y-intercept, you set x equal to 0. You okay with that? Can you spend a little bit of time on example 6? Let's look at that. Okay. Again, very similar to example 5. So for x-intercept, you set y equal to 0, and you get 4x squared plus 0 squared equal to 4, or 4x squared equal to 4, or x squared equal to 1. Now you take a square root on both sides, you get x equal to plus minus 1. So the x-intercept are negative 1, 0 and 1, 0. Okay, so that's for x-intercept. Now for y-intercept, you set x equal to 0, or you get 4 times 0 square equal plus y square equal to 4, or y square equal to 4. Then take the square root on both sides, you have plus minus 2. And therefore, the y-intercept are negative 2, 0 and 2, 0. Yes. Yes, sorry. So 0, negative 2 and 0, 2. Sorry. Good. Sorry. Any questions on finding intercepts graph equation? Oh. Now I'm going to move on to symmetry. Again, there are 3 types of symmetry that we're going to look at in this lecture. There are other types of symmetry that we will encounter in this course later on. So a graph is said to be symmetric with respect to the x-axis. So this is symmetrical with respect to the x-axis. So a graph is said to be symmetric with respect to the x-axis if for any point x, y on the graph, the point x, negative y is also on the graph, right? So y is positive on the positive part. Now we reflect that to the negative part. All right. So therefore, the graph is symmetrical with respect to the x-axis. But that's the first image that we see. So symmetric with respect to the x-axis. The second graph is for the graph that is symmetrical with respect to the y-axis. We say that if you have the point x, y on the graph, the point negative x, y is constant. So x on the positive side get reflected to the negative side and vice versa. You with me on that? Andrew? So this is symmetric with respect to the y-axis. Then the last image you see here is that the graph is symmetric with respect to the origin. If you consider the point x comma y on the graph, then corresponding point negative x and negative y also on the graph. This really quick. So this is symmetric. With respect to the origins. So these are the informations for symmetry of a graph, right? So the graph can be symmetric with respect to the x-axis, the y-axis, or the origins, or all of them. We'll see. All right, so let's take a look at this graph. Right. So from here, we can assume the x-intercept, the y-intercept, and the type of symmetry for each of the following graphs. So for the first graph, can you identify the x-intercept, the y-intercept, and also the type symmetry? Okay, so for the x-intercept, now what are the x-intercepts? Okay. X-intercept. Yes. -2, 0, 2, 0. Okay, so -2, 0, 0, 0. Good. So -2, 0, 2, 0, and then 0, 0. Good. These are the x-intercepts. What about the y-intercept? Yeah. 0, 0. Very good. Now the type of symmetry. Let me see here. Origin. Very good. All right, let's move on to the next graph. Can you identify the x-intercept, the y-intercept, and the type of symmetry? Right, x-intercepts. Yes, those are the numbers. What about y-intercepts? Mm-hmm. By the scale of it, I could say -2 as well. So 0, -2. All right, can somebody else tell me type of symmetry that graph? respect to the y-axis. Any other question? Any other answer? Yes. None. Right. So it's not really symmetrical with respect to the y-axis. So this parabola is actually symmetric with respect to the axis of symmetry that we're going to look at specifically for parabola, right? But it's not symmetrical with respect to the y-axis. So none for this one. The next graph, the x-intercept, so it's not going to be very clear. So I'm just, let me put down the solutions. Negative 1.2, 0 and 1.2, 0 for the x-intercepts. And for the y-intercept, it's 0, 5. Right. Now for symmetry, what type of symmetry? Yeah, now this one is symmetrical with respect to the y-axis. Any question on these three graphs? So we have three more graphs to work with. So x-intercepts is negative 1, 0. Y-intercepts are negative 0, negative 2, and 0, positive 2. Symmetry, type of symmetry. So this graph is symmetrical with respect to the x-axis. You agree with me on this, right? Okay. So the next one for x-intercepts, including negative 3, 0, 3, 0 for y-intercepts. You have 0, negative 3, and 0, positive 3. What type of symmetry is this? Origins. Okay. Right. So by the look at the graph, you can also conclude that can be symmetrical with respect to the y-axis, symmetrical with respect to the x-axis, but more generally, it's symmetrical with respect to the I'll move a little fast because we almost out of time. I have 2 more minutes. So for the last graph, the x-intercept is 0, 0. The y-intercept is 0, 0 as well. And for this graph, there's no symmetry. Right. Any questions? All right. So tomorrow we will continue with this lecture and we're going to find the type of symmetry of. Okay, so for the intercept, the y value is always equal to 0. So you set y equal to 0 and you solve for the value of x. Then you have x squared plus 4 equal to 0. And then when you solve for this, you get x equal to -4. So when you have x equal to -4, that means there's no solutions here. So there's no x-intercepts. You with me on this, right? So because x squared is always non-negative, therefore when you have x squared equal to -4, you say that there's no real solutions. So you say that no x-intercept. Well, let me do this. No real solutions implies that no x-intercept. And then for the y-intercept, you set x equal to 0 and you solve for y. So 0 squared plus 4, implying that y equal to 4. And you conclude that the y-intercept is 0, 4. All right. So from my own experience, I know exactly the type of symmetry for this particular curve, right? For this particular graph. But assume that we don't know about the shape of this graph. We have to try all three cases, right? To make sure that we see the symmetry with respect to the x-axis, with respect to the y-axis, or with respect to the origins. And we have to try three cases. Now, for the x-axis, what you do is you have to try the point x comma -y. For the y-axis, you try the point -x comma y. And for the origins, you have to try the point -x y. Now, what do we do with this information? So you try this for x comma -y. So you just substitute into the original equation. Okay. And then after that, you manipulate the resulting equation. If the final answer match with the original equation, then you say that the graph is symmetrical with respect to the x-axis or the y-axis. Okay, so let me demonstrate that. So you substitute x, right? So x is equal to x, but y in this case now replaced by -y. Okay, so you have -y equal to x squared plus 4. And you see that, let's try set y equal to something, right? Set y by itself or solve for y by itself. So I'm going to multiply both sides by -1. And I get y equal to negative of x squared plus 4. And you see that clearly this is not the same as the original equations. So therefore, there's no symmetry with respect to the x-axis. Okay. So you conclude that there's none here. Now for the y-axis, you have the point negative x comma y. So x now replaced by negative x, y is the same. Okay. Substitute this point to the original equation. This is what you got. So I'm going to use a different color here. So y equal to negative x altogether square plus 4. And you have y equal to x squared plus 4. And you see that this match with the original equation. So therefore, you conclude that the graph of these equations is symmetrical with respect to the y-axis. Okay. All right, symmetric with respect to the y-axis. Now for the origins, again, you use this point, negative x, negative y, substitute this point to the original equations, right? So x replaced by negative x, y replaced by negative y. Let's see what you get. So here you have negative y equal to negative x squared plus 4. So you have negative y equal to x squared plus 4, or y is equal to negative of x squared plus 4. And it doesn't match the original equation. So therefore, you conclude that there's no symmetry with respect to it. You okay with it? So you're saying none here. Questions? All right. So let me try with the next example, y equal to negative x cubed minus x. But I'm going to ignore or omit the calculation of the x and y intercepts. Okay, I'm just going to focus on the symmetry only. We have enough exercises, for example, for the x-intercept and y-intercept. All right, so let me try with symmetry only. So the x-axis is the y-axis. Here's the origins. All right, so the x-axis, I'm trying the point x comma negative y. For the y-axis, I'm trying the point x comma y. And for the origins, I'm trying the point negative x, negative y. Again, what I'm doing is that I'm substituting this point into the original equations, manipulate the resulting equation, and hopefully I have a match with the original equation. If there is a match, you conclude that the graph is symmetric to whatever, x-axis, y-axis, or the origin. All right, so this is the original equations. All right, x is just x, y is replaced by negative y. So I got negative y equal to negative x cubed minus x. And then I want to solve for y by itself. So I multiply both sides by negative 1. So I get y equal to negative of negative x cubed minus x. And clearly this is not the same as the original equations. So you conclude there's none symmetry. There's no symmetry with respect to that fact. Now let me try with the y-axis. So x is replaced by negative x, y stay the same. Okay, so I have y equal to minus negative x cubed minus negative x. When there is a negative number, as you can see, I'm very careful to include the parentheses around it. So negative x raised to a negative power, raised to an odd power, you still have a negative number. So this is going to be negative x cubed. Okay. So with the negative in front, negative with negative positive. So you have y equal to positive x cubed. And then you have negative with negative x become positive x. So again, this is different from the original equation. So there's no symmetry with respect to the y-axis. And for the origins, I do, so y replaced by negative y and x replaced by negative x. So negative y stay the same for now. I'm going to manipulate the right-hand side. Any questions? You follow? Okay. So again, negative number raised to an odd power, we still have a negative number. Negative with negative become positive. So positive x cubed plus x. And you solve y by itself by multiply both sides by -1. Have y equal to negative of x cubed plus x. Or y is negative x cubed minus x. So this matches the original equation. So you conclude that the graph of the equation is symmetrical with respect to the origins. Or symmetric with respect to the origins. Any questions? So if you don't have any questions, I could ask you to spend a little bit of time on C and D by yourself, or you can talk to your friends if you want to. So C and D, again, try to find if the graph of the equation satisfy or symmetric to the x-axis, y-axis, or the origin. So give it a shot and see how it goes. So you have negative y squared equal to negative x plus 4. Right, so x is just x, the same. Right. So now negative y raised to the second power, it's going to be y positive y squared equal to negative x plus 4. And this is the same with the original equation. So you say that is the graph is symmetric with respect to the x-axis. Now for the y-axis, you have the point negative x comma y. Then you replace this, or you substitute this into the original equations. You should get y squared equal to negative of negative x plus 4. All right, so again, technically what you did is you replace x by negative x. You follow. So the right-hand side now equal to x plus 4. So it's different from the original equation. So you say that there's no symmetry with respect to y-axis. And for the origin, you get the point negative x comma negative y. Again, you replace x by negative x and y by negative y. And you have negative y squared equal to minus negative x plus 4. So you get y squared equal to x plus 4. And again, this is different from the original equation. So you say there's none. There's no symmetry with respect to the origin. What time do we have to go today? 1:20? Okay, so we almost out of time. So let me do the last example as well. Any questions on C? Okay. So for D, again, you're gonna try x-axis with the point x comma negative y. For the y-axis, choose the point negative x comma y. And for the origins, you work with the point negative x, negative y. So for the x-axis, right, x stay the same, y is replaced by negative y. So you have x. So you have x squared plus negative y altogether square equal to 25. And you get x squared plus y squared equal to 25. And it matched with the original equation. So you conclude that this graph is symmetrical with respect to the x-axis.